reflecting on those and thinking about year 4 and beyond. Again, not premeditated by any stretch, but it pretty quickly became aware of us and most folks in this room that this wasn't just a change in a simple image format, but this was actually a change in how we're going to architect applications. And we've all been around for a while, and these changes in the stack, they don't come through every year, right? They come through every 8 to 10 years when everything in the stack just kind of says, whoop, all right, we're gonna redo it. And you can see kind of the major shifts behind me here. And whether you call it microservices, whether you call it containerization, cloud native, whatever label you favor, this is the next 10 years. Right, and we're just getting started, and we would say that we're, you know, if Basecamp and the kickoff for democratization was March 2013, we would say we're only at Camp 1 now, right? We've got a ways to go, because these decade-long shifts take a long time for the users and the customers to get comfortable and to have the services and the full tooling that they need. It takes a while for all of us to mature the interfaces and create the technologies and the plugins and the ecosystems to make that all work for them. And so it's a lot of work. So what can we learn from the first 3 years of democratization that'll help us in the next 3 years? So I have some thoughts. I'll share them. Grab me afterwards and tell me I'm crazy, tell me to double down, somewhere in between. We have to continue to make it accessible for those not in this room. The first 3 years were good, right? I mean, enterprise IT is going nuts over Docker containers. Cloud Foundry is a great partner in helping them adopt it in their segment of the market. Lots of other partners in the room. I see Jason IBM in the back. Like there's lots of enterprise IT interest, but it's the early edge of the enterprise IT market. It's not the laggards, right? It's not, I won't name vendors who sell to those laggards, but there's a whole half of the market, at least, two. To the Windows community. Portability 2.0, what does that mean? The promise of portable in 1.0 in the first 3 years was the individual container. It was the developer or sysadmin could create that container, Its only dependency was a Linux kernel, so it could go from Red Hat to Ubuntu, go to the cloud, go to OpenStack to the data center, all without needing to be changed. But again, as we've realized over 3 years, a single container typically does not a full application make. Applications are combinations of containers, and applications need networking and storage and security. And we would assert that we need, as a community, to maintain the promise of portability in multi-container, multi-host, networked, persistent applications, as we did with the single containers. And just, this is a simple example of a format that Docker has, Docker Compose, but there's a lot of formats out there that are multi-container formats. This can be created on a developer's laptop, moved to the cloud with multiple containers, multiple hosts, moved back to the data center. Different networking stacks can go from a Cisco stack to a VMware stack, all without breaking the application portability. In order to make containerized apps accessible, to democratize them further, we need to maintain, we as a community need to maintain that promise to the next wave of adopters, to the next wave of users. And finally, third, there's a evolution, if you will, of how we work with each other and how we promulgate standards. Honestly, OCI and Cloud Native Computing are good examples of this. OCI, Open Container Initiative, is the de facto standard of the Docker image format and the Docker runtime, and its purpose is to continue evolving that standard and to support its adoption. Whereas, as we spoke earlier, Cloud Native Computing Foundation, higher in the stack, lots of innovation still going on, and its responsibility is instead to focus on reference stacks to help make the whole stack from metal to top of stack adoptable by organizations. Figuring out here within this room how we complement each other and work together, and then how we communicate that in very clear language to the market, because the market does not get this distinction today, is, I would say, a responsibility for all of us to help promote further democratization and not have the market get concerned and push back and say, well, we'll wait till you guys settle this out, because until you do, too much risk on us to adopt. None of us in the room benefit if that happens. All right, which brings us to today. More time, so I'm going to be quick. Look, events like this are great for checking our tools and checking our gear together as a community. It's great for checking our maps, making sure we're going in the roughly same direction, heading toward the same objectives as an organization and community. And
and how we can actually work together better. I mean, we're here in Linux Collaboration Summit, and I think Provider to provide me that infrastructure, but I want to run isolated from everybody else. So I'm okay being outside the walls of my enterprise, but I'm not okay with sharing resources deeply with other users. And so there's a need for both public, dedicated, off-premise infrastructure on which to run a cloud. There's also a need for what we call local, meaning I need cloud capabilities, but I need it inside a data center that I control as an enterprise. I need it inside my walls or inside an environment that I can control. So public, dedicated, and local are three delivery models, three infrastructures that cloud has to deliver on. And what a lot of people want is some consistency across those three environments. They want one set of APIs and one experience across those three delivery models. Now, on top of that physical infrastructure, you need a set of infrastructure services. You need support for virtual machines. You need support for networking, both core networking and networking services like load balancers and firewalls and packet inspection and DNS and CDNs. You need support for storage, whether that's block or object, archive or backup. All of those core infrastructure capabilities are really important to provide in a cloud environment. And even for people who are adopting a cloud-native microservices architecture where the platform they're building on isolates them from that infrastructure is still there, those services are still there, and they provide the fundamental underpinnings that support the platforms that ride above. Now, of course, a lot of us live in application space. We live in platform space. And what we need in the platform space, I think, is really two things. You need a set of core runtime models that support application development effectively with the speed and agility that we've heard this afternoon. That could be Docker container-based applications. That could be Cloud Foundry-based applications. That could be emerging models like a few weeks ago, IBM announced an open source project called OpenWhisk for serverless event-oriented programming in the cloud. But you need this variety of runtime models, and then you need a set of foundational services to help you build those applications. No matter how you build your app, you need to figure out logging and monitoring and alerting. You need to figure out how to do delivery and update. You need to be able to figure out how to do security and how to deploy software. So there's a set of common capabilities, integration capabilities that exist for all applications that run on the cloud. And then finally, I think there's a set of domain-specific services that you expect to see. That could be cognitive or AI services, machine learning. That could be data. It could be analytics. It could be video, Internet of Things. These are services that you want to take advantage of in the cloud. They're in a particular domain or realm, but they're still important capabilities that you can build interesting and compelling applications on top. So as I think about the modern cloud stack that we're building in IBM, I'm thinking about this whole entire picture and how we bring that together and how we deliver that as a single coherent platform that users can adopt and build and run applications on top of. Now, as I hope is not a surprise to anyone here, IBM really believes in open. We believe in open source, we believe in open communities and open governance, and we have built our strategy for years, both in the cloud space and in the traditional software space, on top of a strategy whose underpinnings are based on open source. And the cloud space is no different, and there's an amazing amount of innovation happening in this room and outside this room in the cloud space. And so how does open source layer into that picture I showed? How do you build a modern cloud stack where all the layers within that stack are built on top of open source capability? And so this is how we're building the stack. This is how that layering maps in our mind to open projects. At the base, we're using OpenStack. And OpenStack provides the compute, storage, and network resources that are needed both directly by users who are deploying applications and in support of the layers that ride above. At the platform layer, we have worked with containers, with Docker directly, and with the work that we're doing together in places like OCI and CNCF, Cloud Foundry, and OpenWhisk as an example of something that we've created that we want to do together with the community to start to have an open source model around serverless and event-oriented computing. In the foundational services space, there's a mix. There's actually a lot of activity around things like proxies and service discovery. There's a lot of great open source innovation in that space. But there's a lot of it, and there's a lot of different approaches for how you might solve those problems. In the logging space, we're using things like Elasticsearch, Kibana, and Logstash as the underpinnings for how we're doing things like logs and metrics within the cloud. If you go up into the application space, I mean, I'm from IBM, so I'm sure you guys know that we love Java, and we've done Java for many years. But we don't just do Java. We have a huge focus on things like Node.js. We've played a role in helping bring the Node.js community together and really supporting that community. A lot of new applications that we're building and that our clients are building are built on top of Node. And you have new things like Swift, right? Recently, Apple, with some help from us, have open source Swift. And we have started to build capabilities to run Swift on the server, to run Swift in cloud, to run Swift underneath Cloud Foundry and in Docker containers, and to help developers build web applications on top of Swift. So runtimes and open source runtimes play a really key role. And then up in those domain services, you have things like Spark. You have things like, in the data space, we have an offering called IBM Cloud that's really Apache CouchDB under the covers from an open source perspective. And you have things like the Open API Initiative and Swagger, helping to define how we all go build APIs and how we expose those APIs to each other. So I think the message here is that you can build a modern, capable, compelling cloud stack, all based on open technologies. But there are challenges that go with this. And so what I want to do is spend a few minutes talking about some of the challenges. And I don't mean this in the spirit of we're doing anything wrong, but more in the spirit of how do we start to think together about that full picture and how all the different pieces we're working on might come together. I think there's two big challenges that I see as I try to bring that stack together for IBM and build a coherent experience. One is, no surprise to any of us, there's a ton of overlap between all of our projects. There's a ton of projects who started in a certain domain. They started looking at an infrastructure perspective of the world or a container perspective of the world. They've looked at the world from a certain lens, and then from that lens, they've expanded out. And so we've all solved networking in a different way, or we've solved storage in a different way. So there's lots of overlap. And in isolation, that's fine, right? But as you try to bring things together, that becomes more complicated. The other big challenge, I think, is how do you connect all these pieces together for a consistent experience? How do you actually build a cloud stack out of open technology that doesn't look like 65 projects that were glued together, that were never meant to actually work together? So let me dive into maybe 3 examples, specific examples of where we're trying to work through some of these challenges as a way to motivate the conversation. Take the networking landscape. Take specifically the container and infrastructure networking landscape. If you just look at, and these are not meant by any means to be exhaustive, but if you just look at some basics, within OpenStack, within the Docker community, within CNCF, within Cloud Foundry, everyone's trying to figure out how do we expose networking with an abstraction that makes sense for infrastructure applications that under the covers is pluggable to the physical network infrastructure and control plane that we want to use. In OpenStack, we have Neutron. In Docker, we have libnetwork. In CNCF, we have CNI. In Cloud Foundry, we have, I think, an active discussion. Some days it seems like it's CNI. Some days we're talking about how CNI maybe isn't quite do everything we need. Everyone has invented their own abstraction that's pluggable, which is great, but different, a different view of how you expose networks. So as an application developer, I have to kind of get my head around these different models, and I have to, in some cases, pick which model I'm going to use and leverage and exploit. We ran an experiment as we were building out our container services, looking at how do we actually just connect all these things together. So we built a stack that looks like this. I have Kubernetes talking through CNI to libnetwork and Docker, talking through the Courier project to Neutron, down to OVN and OVS. The good news is it works. The bad news is I feel really bad for the ops team that's going to have to run all this stuff and figure out what the heck went wrong when a container came up and can't talk to anybody or the network goes away. So there's a complex stack of abstractions that are coming together within this space. Second example, container orchestration, right? There's not enough room on the chart to talk about all the different flavors of container orchestration that are brewing right now.
These they're actually based on work we've been doing for about 15 years, but we're actually trying to create a new generation that can take advantage of all of the new technologies that we've been hearing about today. And from our side, this is really important because what we're looking for is advice and collaboration and all of those sorts of things to help us drive these new systems forward. I should also